So in this video, we're going to talk about how do we actually write up an entire problem for a confidence interval. We're going to talk about a one sample proportion here. And remember, when we talk about a confidence intervals, we use confidence intervals when we simply don't know something. So if you don't know something, you're going to use a confidence interval, all right? And that's important because there's two types of inference procedures you're going to do. It's either going to be a confidence interval or a hypothesis test. So remember, confidence interval is always when you don't know something. So when we see a confidence interval, the first thing we're going to think to ourselves is the mnemonic panic. And remember, in panic, the P stands for the true parameter in context. In this particular case, we're going to talk about proportions. So this will be the true proportion. The A stands for the assumptions. We need to check our assumptions. And we basically have three assumptions for each one of our things there. And we'll go through those when we get to those two things too. You're going to name the interval. If you forget the name, remember, we're going to look in the calculator to find out the name. You're going to actually construct the interval. If you can, try to fill it in by hand. If you can't, we're going to just go ahead and use the calculator to find the interval, and then we're going to make a conclusion about it, all right? And this conclusion is just one general blanket statement. So here's the problem we have. And it says a company is willing to renew its advertising contract with a local radio station only if the station can prove that more than 25% of the residents of the city have heard the ad and can recognize the company's product. The radio station conducts a random sample of 400 people and finds that 80 have heard the ad and recognize the product. Construct a 90% confidence interval for the true proportion of residents that have heard the station and can recognize this ad. Be sure to interpret this interval. So the first thing we're going to do is we know it has to be an interval, and then we know what level it's at as well, but we're just finding a confidence interval. So this means we're going to panic. And so I'm going to start out by saying P, the true proportion. This is the true proportion of residents. And look, it tells me what P is right here. The proportion of residents that have heard the station and can recognize the ad. So this is the true proportion of residents that have heard the station and can recognize the ad. So that's what our P is. And then the next thing we're going to do is we want to talk about our assumptions. Well, pretty much for every test, every interval that we run, we're going to have three assumptions. The first one is the random assumption. And if you look here, we're going to go in this problem, and we want to see if it's stating that it's random. And it tells us that they're taking a random sample here. It tells us right here they're taking a random sample. So that's going to be stated already for us, which is nice when it's stated. If it's not stated, we can assume it, but we need to give a reason why we're assuming it. So this is stated. The second assumption, when you talk about a proportion, is what we call success failure. And in success failure, remember, your successes have to be greater than 10. So N times P has to be greater than or equal to 10. And also N times Q has to be greater than or equal to 10. Well, we know that from our particular sample here, we know that 80 people have heard the ad already. Those are my successes because that's the people that I'm interested in, the true proportion of these people. So those 80 people are my successes, so 80 greater than or equal to 10. And it's out of 400 total people, so that means that 320 people are my failures that have not heard the ad and can recognize. Both those are greater than 10, though, so success failure is met. And then the third thing that we need to show is that our 10% rule, our independence. And independence is shown through the 10% rule. So we'll say, surely, remember the sample that you took, surely 400 residents are less than 10% of all residents who have heard the ad. Now, when we name this, remember, we can go to our calculator if we get the name, but we're dealing with a proportion. It's one proportion. If you go to your calculator and then you look at your intervals, you'll see that it says one proportion. This is a one proportion Z interval. And we want to state our level of confidence here as well. And our level of confidence, alpha is equal to, though they said at a 90% confidence level. So we're going to state alpha to be, we're going to state alpha or the confidence level, actually. not alpha. We're going to state this to be 90%. So that's 90% confidence. And then I want to actually construct the interval. If I can remember it, I know the interval is p hat plus or minus e. And you can actually write out what the interval is, and this would be actually equal to p hat plus or minus e is z star times the square root of p hat q hat over n. Now, for this particular problem, p hat, there were 80 successes out of the 400 people. So our p hat here is going to be equal to 0.2. And so now we can go and calculate the rest of this by plugging in what we know. We know that p hat is 0.2 plus or minus the z star at 90% is 1.645 times the square root of p hat 0.2 times 0.8 divided by my n, which is 400. Now, once I have this typed in, I'm not going to calculate this interval by hand. I'm actually going to plug this into a calculator and let it do it for me. Now, to do that, we're going to go menu 665. And when I go menu 665, it brings up the confidence interval test, the confidence interval for me, the one proportion z interval. And it wants to know the number of successes. Well, if we come back into the problem and we look for the number of successes, it tells me that 80 people have actually heard and recognized the ad. So here for success, I'm going to plug in 80. And then it goes to my n. So when I look at the n here is going to be 400. And the level of confidence, C level, I'm going to put it at 90%. I have to use that as a decimal, so that's 0.90. And when I press OK, I see that my lower bound here goes from 0.167 up to my upper bound, which is 0.233. And so now, once I have this part written, the bounds written, I can go ahead and interpret what this interval actually means. And what this really means is that we always use this blanket statement to start it. We are the confidence level here, which is 90%. We are 90% confident that the true, and we can actually put, because we've defined the parameter, because we've defined our parameter up here for P, we can actually put that the true P, and that stands for the true proportion of residents that have heard the station that can recognize the ad, lies in the interval from 0.167 to 0.233. And then the final part of this is to actually answer the question what was asked of us. And that question is actually, it says the company will only renew its advertising contract with the local radio station only if the station can prove that more than 25% of the residents of the city have heard the ad and can recognize the company's product. Well, here, from our sample, we're looking at this interval here. In this interval, we see that if 25% of the people actually can recognize the ad, we should have 25% sitting inside this interval. But because it is lower than the entire interval is below 25%, we can say that based on this interval, or that based on the interval, the company should not renew the contract. Why should they not renew the contract? Well, the entire interval is below 25%.